Okay, so the idea is, given a function, we need to sketch the graph of the function and its reciprocal, labeling the intercepts, the asymptotes, the invariant points, and other key points, right? So we want to be pretty systematic about this. Right? The question is, so how are we going to go about doing this? So the first thing is, I think, well, we know we have to do the reciprocal, right? So the reciprocal is 1 over 3 x plus 6. Which is 1 over 3 times x plus 2. So what's the restriction here? Negative 2. So that tells us there's going to be a vertical asymptote at negative 2, right? Now, we can also just go graph this thing. We know it's a straight line. What characteristics does it have? The original function. The y-intercept of 6. And it's got a slope of 3, right? So 1, 2, 3 up and 1 over. Or 1, 2, 3 down and 1 to the left. And I just like to keep plotting points until I run out of room, which I have now done. Run out of room. So we can graph our original function. And you know what, let's actually put a straight line now. 3x plus 6. Yeah, lines are bad whether I do them with the thing or not. There's line 3x plus 6. We're going to get a vertical asymptote at x equals negative 2, right? That's our x-intercept. So x-intercept, the first thing you do is you sketch out the vertical asymptote, right? Because the x-intercept is where y is equal to 0. When we're graphing the reciprocal, we're doing 1 over y. Right? Remember, the point xy becomes the point x, comma, 1 over y. And so we can't do 1 over 0. Do we have any horizontal asymptote with this? So as these x values get really large, or look here, I guess, as the x value gets really large, we've got 1 over a very large number. What's 1 divided by a very large number? Very small number. So there's a horizontal asymptote. At y equals 0. Okay, so we can sketch in that asymptote as well. Okay, so I've done the asymptotes. So the next thing we're looking at is invariant points, right? The invariant points, where do they occur? Nope. Invariant points when y is equal to 1 or negative 1. Now, I can't really tell what that point is, right? It's not passing through a nice grid intersection. So all we have to do is go and set 3x plus 6 equal to 1, right? If I want to find the invariant points. So let's note that, invariant points. Okay, the invariant points occur when y equals plus or minus 1. Now it doesn't matter which equation I use, 3x plus 6 or 1 over 3x plus 6. So the easiest one is just to use 3x plus 6. So when is 3x plus 6 equal to 1? When 3x is negative 5 or x is negative 5/3. And when is 3x plus 6 equal to negative 1? When 3x is equal to negative 7, and x is negative 7/3. So my invariant points, right, asks us to specify them, I think, right? This is label the intercepts, the asymptotes, invariant points. So the invariant points are negative 5/3, comma 1, and negative 7/3, and negative 1. So we have negative 5/3, 1, and negative 7/3, and negative 1, right? Those are invariant points. But we need to state what they are, okay? And if it went through nice numbers, we wouldn't necessarily have to do the work, okay? But here we have to do the work, right? We have to show this is where y is equal to 1. This is where y is equal to negative 1. Okay, intercepts. So where does this intercept, right? When is 3x plus 6 equal to 0? Okay, negative 2. Well, okay, or sorry. So the intercept, how do we make y equal to 0? What value of x makes this 0? Can't do it, right? We can't get this expression to be 0. There's no y-intercept, right? That's why we end up with this asymptote here. Okay. Now, so the x-intercept is when y equals 0. The y-intercept is when x equals 0. So what's the y-intercept? So y-intercept 1 over 3 times 0 plus 6 is 1 over 6. Right? Now we can get that from the graph too, right? This goes through 6, so the reciprocal is 1/6. Okay, so we have no x-intercept, and the y-intercept is 1/6. Remember, y-intercept, when we talk about it, is just a number, right? The coordinates of the y-intercept are 0, 1/6. We don't talk about that, right? We talk intercepts, we're just talking numbers, 1/6. Okay, so we know what happens here. This guy is going to, as these values get larger, these values get smaller. So our curve is just going to drop down and approach the asymptote from above. As these values get smaller and go down to 0, what happens to these values? They go larger, right, and climb up. So, this y value here is 1/2. Well, the reciprocal of 1/2 is 2. And then this one is 1/4, so the reciprocal is 4. And we just climb this asymptote with a straight line. See if I can undo that and draw it a bit straighter. Okay, arrows on both ends. Okay, do you think you can sketch what happens on the other side? All right, so do it. Make sure you're using a pencil, something erasable. So these guys get larger, their reciprocals get smaller. These values get smaller, reciprocals get larger. And away we go. And away we go. Down, 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 down. All right, so we have shown the asymptotes. We should write in the equations of the asymptotes. Be a good thing to put in. Y equals 0. X equals 2. Sorry, you're right, negative 2. We have the coordinates of our invariant points. Okay, we can sort of set them apart. Say here are our invariant points where y is 1 or negative 1, and there are their coordinates, and there's the y-intercept at 1/6. Okay, there is no x-intercept, so other key points, right? So intercepts, we've got the 1, yeah, done that. Asymptotes, done that. Invariant points, done that. Other key points would just be basically, you can say, well, if that's 4, then this is going to be 1/4. If that's 2, this is going to be 1/2. Okay, but we know the shape. All right, any questions on that first one? Nope. Okay, let's go on to the second one. So f of x is x squared minus 2x minus 8. So, what do we know about it? It's quadratic, right? It opens up. So we've got a quadratic that opens up. So quadratic. Right. So I'll disappear in a moment. What other characteristics does a quadratic have? It's got a vertex, so we want to find the vertex. What else? Got an x-intercept, y-intercepts, right? So if we set it equal to 0, this looks like it's going to factor. We can find the x-intercepts. If we set x to 0, we can find the y-intercept, which is -8. We can put it into vertex form, so we get the vertex. So that's basically what we're going to do, right? We're just going to do what we've done with quadratics. Now that it's all disappeared, we can start. So it's a quadratic. It opens up. We get x minus 4, x plus 2 equals 0, gives us the x-intercepts at 4 and -2. Okay, so y-intercept is -8. And if we want to put that into vertex form, then what do we do with vertex form, right? Y equals x squared minus 2x minus 8. Minus 2x minus 8. Half of 2 is 1, so it's x minus 1, quantity squared. And then what do I have to do up here? I'm going to have to add 1. And then out here, we're going to have to subtract 1. Okay, so the vertex is where? 1, -9. All right, so we could do a pretty good sketch now of the original quadratic, right? We've got a vertex at 1, -9. Got a y-intercept at 8. By symmetry then, we have this point, right? If we move 1 unit to the left of the axis of symmetry, then we move 1 unit to the right. We have intercepts at +4 and -2. Right? So if we go over 2, we should go up 1, 2, 3, 4. And 1, 2 this way, 1, 2, 3, 4. And if we go over 4, then we should go up 16. So that'll put us at 7. And put us at 7. All right, so we should get a very accurate sketch of the original quadratic, right? So what we say now is, okay, great, that's all the quadratic stuff, right? We want to graph 1 over x squared minus 2x minus 8, which means that we should then be writing this in the factored form, right? So we could say what x is not equal to, which is -2 and 4, which gives us our vertical asymptotes, right? So vertical asymptote, x is -2 and 4. Bless you. And we know that because we can see that's where our zeros are, right? So if I just gave you the graph and said sketch this without the equation, then you could. So we can sketch in this asymptote. asymptote. Yeah. I drag this down a bit. Okay, so our horizontal asymptote. So as x gets really big, what happens to this? It gets really big, which means that this gets really small, which means the horizontal asymptote is
0.
Y equals 0. Yeah. Okay. So we sketch a vertical asymptote, and we sketch our horizontal asymptote. Right. Now, what we did yesterday, we could draw this right now, right? We know what this looks like. But we should find some points, right? So let's drag down. Well, what do I need? Invariant points, right? Invariant points are going to be, what color? Invariant points are going to be here, and here, and here, and here. Now they don't look like nice numbers, right? So we got to figure out where are they, right? So the invariant points, we need to work out x squared minus, so invariant points, that's what we're going to do now. Invariant points. So I need to work out where x squared, I'm just working on the original function, right? X squared minus 2x minus 8 is equal to 1. And we're going to solve that, right? We're going to find the values, and we know there are two of them, right? Because we can see them on the graph. We can see there are two places where x is equal to 1. And they're not nice numbers. So we want to solve the quadratic, x squared minus 2x minus 7 equals 0. It doesn't factor, right? The numbers that multiply to 7 are 1 and 7, and I cannot combine those to get a 2.
Minus 9.
Right, minus 9. The other one's going to be minus 7. Good catch. Wouldn't have been waste time. I would just have to change that to a -1, which we need to do anyways, but yeah, we should solve the one wrong. Okay, so two numbers multiply to 9 and differ by 2. No, it's 1 and 9 or 3 and 3, so we cannot factor. It does solve, however, because we know that b squared minus 4ac, right? If a is positive and c is negative, b squared is always positive, and then you're subtracting a negative, which means you're adding, so there are two solutions. Right, now, we know there are two solutions because we can see there are two solutions, right? There are two places where x is equal to 1. So, what are they? We're going to have to use quadratic formula. Okay, so x is equal to -2. I'm just going to write that as 2. Plus or minus the square root of -2 quantity squared. Right. Make sure there's brackets around that -2, right? Because when you square it, you have to get a positive. Minus 4 times 1 times -9, right? Now we knew that would have to work out to, minus a negative. It's going to be, since c is negative, you're subtracting a negative, that's going to make this positive. Over 2a, 2 times 1. So 2 plus or minus root, so we've got 4 plus 36 is 40. Okay, so it's 2 plus or minus root 40 over 2. Just 2 plus or minus 2 root 10 over 2, right? So root 40 is 2 root 10. Okay, use that because the next unit is radicals, and you might want to review radicals prior to the next unit, right? Going from mixed to entire and so on. And we divide that out, so we get 1 plus or minus root 10. So that gives us two of the invariant points, right? 1 plus root 10 comma 1. So root 10 is going to be a little bit over 3, right? Because root 9 is 3. So 1 plus root 10, 1 plus a number a little bit bigger than 3. So here we are, 4 and a little bit. 1 minus root 10, 1 minus a number a little bit bigger than 3 is going to take us down below -2. So those are in about the right places, right? And we have two invariant points where x squared minus 2x minus 8 is equal to -1. So we're just going to run through the exact same thing, only this time we're going to have a 7. Instead of a 9, x squared minus 2x minus 7 equals 0. Still using quadratic formula because we can't solve this. So 2 plus or minus negative 2 quantity squared minus 4 times 1 times negative 7 over 2 times 1. Alright, and we just keep going. So 2 plus or minus root. So I've got 4 plus 28 is 32, right? So this is 32 over 2, which is 2 plus or minus 4 root 2. So root 32, the biggest perfect square that goes into 32 is 16. Right? So 32 is 16 times 2, so it's root 16 root 2 or 4 root 2. Right? And really, by this time, you need to just be able to look at root 32 and go to 4 root 2. Okay? And we divide everything by 2, so it's 1 plus or minus 2 root 2. So our invariant points. Are 1 plus root 10, comma 1, 1 minus root 10, comma 1, 1 plus 2 root 2, comma negative 1, and 1 minus 2 root 2, and negative 1. Okay, so we got to list those, right? There are 4 invariant points whose exact values, right? When we say exact values, you do not give decimals, right? We say exact values, it means it's probably going to be in a radical form, and I need to do it as a simplified radical, right? I need to get this simplified. So, get that understanding down, right? I hate asking, give us exact values, and you start throwing in decimal, right? You just go, oh, well, this is 3 point, 4 point, whatever. No, it's not. All right, what have we got? We have our asymptote. Oh, we should label them, right? What is this? This is x equals negative 2. This is x is equal to 4. This is y is equal to 0. I've indicated my invariant points. We have some key points. So at 1, we have 9, and the reciprocal will be 1/9. So that's the key point there. We've got some other points we could use. We've got 1/8 here. That's not much lower than 1/9. We've got 1/5. That, but we kind of know. We know what this looks like, right? We know what the middle portion of this looks like, right? So we know that the maximum values would mean negative 1/9, right? That's negative 9. This is negative 1/9. And then values get smaller until we reach the invariant point, which is there. And then these values get smaller, so their reciprocals get larger, and we just go down along the asymptote line, right? And then the same thing happens here. This just stays kind of flattened out, goes through the invariant point, and then down the asymptote. And these guys, these values are getting bigger, so we know that from the invariant point, they get smaller and approach the asymptote. And the same thing happens on this side from the invariant point. And as these guys get smaller, these get bigger, and up we go. Okay, so this was a quadratic. We ran through the full analysis of the quadratic, right? What are the x-intercepts? What's the y-intercept? Right? Those will be key points, right? The x-intercepts because those will be the vertical asymptotes of the reciprocal function. The y-intercept of the original, if it has one, that just becomes a point on the reciprocal. One, in this case, negative 8 is the y-intercept, so negative 1/8. I didn't actually plot that point. I mean, it's tough to really plot negative 1/8. But we do have to find the invariant points. So we set the original equation to 1, right? It doesn't matter which equation you set to 1, they're both going to be the same. But just work on the original, right? It's an easier equation to work with. Set the original equation to 1, solve for x. Set the original equation to -1, solve for x. State those points. And any other key points, right? Draw it. Right, you got 5 steps for drawing. Okay, that's it. So lots of time to practice. So anything you didn't finish from yesterday, work on that. And then there's today's stuff, and the test is in a week, so we still have, more stuff to do. We've got a couple of days on solving equations, Wednesday, Thursday, then applications of equations Friday, review Monday, test Tuesday. All right.